Okay, let's go on. A complex fraction is a rational expression that has at least one fraction in its numerator or denominator, or both. Here are some examples. So here's an example of a complex fraction. We have fractions in my numerator and in my denominator. Here's another one. I have a fraction in my numerator and in my denominator. And here's a really big one. I have fractions in my numerator and my denominator. Sometimes you can simplify a complex fraction by multiplying the numerator and the denominator by the least common denominator of all the rational expressions. You can also simplify them by combining the fractions in the numerator and those in the denominator. Then multiply the numerator by the reciprocal of the new denominator. So here's an example. We have 1 over x plus x over y over 1 over y plus 1. They give us two methods. I'm just going to do one of those methods. So we have 1 over x plus 1. X over y. All over 1 over y plus 1. So the method that I choose to use, I'm going to add my numerator, then I'm going to add my denominator. So first, looking at the numerator, my least common denominator, they have an x and they have a y. So my least common denominator is xy. So in order to make it xy, I'm going to multiply this one by y at the bottom and y at the top. And this one by x at the bottom and x at the top. Because remember, I have to multiply by 1. And I want it to both have xy. So when I do that, I get y over xy plus x squared over xy. Now my denominator, y, I'm going to just kind of cheat here. I know 1 is really y over y. So I can add that now and I get 1 plus y over y. So when I combine my terms, I get y plus x squared over xy all over 1 plus y over y. So now I'm going to divide them. So it's just like division. When you divide fractions, you keep the first term, which is y plus x squared over xy. You're going to multiply and turn this division sign here to a multiplication, and I'm going to flip it. So now it's going to be y over 1 plus y. And that's what they were referring to by multiplying by the reciprocal. And now I'm going to cross out things that they have alike. So here, this x times y and this y, since we're just two things that are multiplying, they're alike, and I can cross out the y's. My y plus y squared is connected, so I can't just cross anything out. So I have to have something exactly like it. And my 1 plus y is also connected, so I can have something just like that, and I don't. So my final answer is y plus x squared over x times 1 plus y. I can go ahead and multiply that out, or I can leave it the way it is. And let's see. I do believe this is what they got as well. They got y plus y squared and then x times xy, which is the same thing if I multiply this. So that would be x times xy. So now let's look at the got it. So I have x over 1 over x plus 1 over y. So I have x over 1 over x plus 1 over y. Again, my LCD is going to be xy. Because I can't do anything to my numerator anyway. And my denominator is the only one that I can simplify. So I multiply the bottom times y and the top times y. And this bottom times x and this top times x. And I get, my numerator stays the same. I get y over xy plus x over xy. And so I get x over y plus x over xy. So now I can flip it. So my first one stays the same, my numerator, so I get x, and I can go ahead and put x over 1 if that helps me out, times, and I'm going to flip this x over y, 2, and then y plus x. So that's that keep, change, flip when we're dividing fractions. And so I can't cross out anything. There's nothing alike. There's nothing in my crosses. If I look here, there's nothing similar here. my y plus x is connected, so I can't cross anything out. So I'm going to multiply straight across, and I get x squared y. And I'm going to flip this around because I like my x to come first. I like it to be in alphabetical order. So to be x plus y. Okay, let's take a look at the last one. Last one is a little bit longer. So here's my problem. For my numerator, my LCD, they don't have anything in common, so it's just going to be x times x plus 1. And for my denominator, again, they don't have anything in common, so it's going to be x minus 1 times x plus 1. So for the first one, I am going to have to multiply top and bottom times x plus 1. And for the second one, I'm just going to have to multiply by x. And we'll go ahead and put for the bottom. For the bottom, I need x plus 1 here, top and bottom. And for this one, I need x minus 1, top and bottom. Okay, so I'm going to multiply now. When I multiply that out, I get, for the first one, I get x squared. I'm just going to go ahead and multiply it out, minus x minus 2. So I went ahead and I did full, and I added my like terms. So I went ahead and did that because I don't want to run out of space on my board. And for the next one, I have x times 2 is 2x all over x times x plus 1. For the bottom one, again, I'm going to multiply it out. I get 3x plus 3 minus x minus 1 all over x minus 1 times x plus 1. Okay, so now I'll combine my like terms. I'm going to go ahead and erase this here. We don't need this. And so I get x squared plus x minus 2 over x times x plus 1 all over, if I multiply this through, this is minus and that's plus. So I get 3x minus x, which is 2x. 3 plus 1 is 4 all over x minus 1 and x plus 1. So now I'm going to keep, change, and flip. So I'm going to keep the first term, which is x squared. Actually, I am going to keep it, but I'm going to factor it first. And when I factor that, I get x plus 2 and x minus 1. So x plus 2 and x minus 1. We know the importance of factoring. And then x times x plus 1 times, and then I'm going to flip this one, so this is going to be x minus 1 up top and x plus 1 up top. And at the bottom, I'm going to factor that. I get 2 times x plus 2. Then I'm going to cross out everything that I have alike. So I have x plus 2 and x plus 2 in my crosses. I have x plus 1 and x plus 1 in my crosses. And that's it. So my final answer is going to be x minus 1 times x minus 1. So I can say x minus 1 squared. And then I have 2 times x. Now this one has, unlike the other one where I just have an x and a y, this one has excluded values. So I have to include all those excluded values. So if I take this x plus 1, this x plus 2, I set those equal to 0. And I get x cannot equal 0, negative 1, negative 2. I feel like I'm missing one. I just took these values here because those are the ones that I was supposed to multiply straight across.